All right, so now let's continue to look at a couple of questions here. Number 11, so it said it's a find the sum of this given series. And 12, it's the same thing. So 11 and 12, the both it's called a geometric series. Okay, so what it does, it's a plus ar plus ar squared plus dot 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 up to ar n plus dot dot dot. Okay, so you can write this one into, I don't know, so k from 0 to infinity a times r to the power of k. Okay, so geometric series converges when this r here, we call it common ratio, it's strictly less than 1. Okay, and it converges to a over 1 minus r. So this a is the first term, and this r is what we call the common ratio. Okay, cool. So those are the backgrounds. So back to our problem here. You see number 11. Let me write it here. We have so basically speaking, I can reorganize my series into this, right? Because they have the same power, raised to the power n. And then our n starting from 0, that's great. So this is, you see the common ratio r is -1 over 2. So it's good. So it converges for sure. So we can apply the result here. That is, first of all, our a is the first term of the series, which is n when n equals 0. So it's a 3 times -½ to the power 0, which is simply it's a 3. Of r, it's -1/2. We know that. So hence, so it converges into 3 over 1 minus 1/2. So it turns out that this result is going to be coming to a 2. So let's see. We got a 2 here. Okay. Number 12, it's exactly the same logic here. Okay, same logic. Because this is the geometric series. This is another geometric series. And so for this one, let me write here. So number 12. So as you can see, we can also handle doing like this. Okay, only those two series are both convergent. Okay, so this one is going to become into 1 over 1 minus 1 over 7. This one is going to become converges to 1 over 1 minus half, because the common ratio for the first one is 1 over 7. The common ratio for the second one is 1 over 2. So I mean they're both less than 1. Between -1 and 1, so it converges, and their first term is all 1, right? Because when you set n equals 0, this part becomes into 1. When you set n equals 0 for this part, it's 1 over 2 to the power 0. It's also 1. So we have 7 over 6 plus 2, and then that going to give us is 19 over 6. Okay, so that's 19 over 6. So we're good. Cool. Now number 13, use the nth term for divergence to show that the series is divergent, or state that the test is inconclusive. So what's the point of the nth term test? Actually, it's super simple. So the nth term test So it checks if series is divergent. Okay. So it said like this: if limit as an is away from 0, okay, then series must diverge. However, if the limit of the an equals 0, it's inconclusive. It can converge, it can diverge. Okay, so nothing guaranteed. So going back to here, you see that this is our an, n over n plus 2. So if you take the limit of an, easily that we got this limit equals 1. So it's away from 0. So that's great. Based on the nth term test, diverge. Done. Simple, right? Okay. The use the integral test to determine whether the series converges or not. So as you learn that, so that's also another series. It's called P series. That is 1 over n to the power of p, summation, and from 1 to infinity. And the P series said that if p is greater than 1, series converge. If p is less or equal than 1, series diverge. And especially when p equals 1, 1 over 1 plus 1 over 2 plus 1 over 3 plus dot dot dot. And this is called the harmonic series, right? So this series actually is also diverged. Okay, so it's very, very classical. Okay, so a little bit mess here. Okay, cool. So even you see, guys, this problem is said that, okay, using the integral test to determine whether the series converges or not. But if you are in a test, it doesn't matter about whether you're going to use which like a criteria, right? As long as you get the correct answer. So my point is here, you see, this series is going to be 9 over n to the power half, right? So, or even better. So do you realize that this is a P series and P equals 1 over 2? Since P is less or equal than 1, so this series definitely, it diverges, okay? So there's no need to use the integral test at all. Cool. Now let's look at a couple of questions here. So one of this is here. So it's again, check whether this series converge or diverge. So I'll show this one with the integral test to give you a sense of, okay, what is the integral test? The integral test actually is it converted this series into the corresponding integral. In other words, n's from 1 to infinity, the integrand, the limit, is from 1 to infinity. I have 2n over n squared plus 4, then I have 2x, x squared plus 4, and then dx. Okay, so that is how do we transform a series into integral. Okay, so that's the transformation. So the integral test says like this. You know, if the corresponding integral converge, and we can get that, okay, the original corresponding series converge. If the integral diverge, same thing, this series diverge, okay. So now, but if this integral exists, converge, the convergent value has no relationship at all with the original series, okay, with the original series. Okay, cool. So only can tell whether it's converge or diverge. Now, what we can do? Well, this integral, as you can see that, this is the improper integral, so 2x over x squared plus 4 dx. So you can evaluate super easily. So this is basically the ln of x squared plus 4, right? From 1 to b, limit b goes to infinity. So you can see, so it's ln of b squared plus 4 minus ln of 5. And noticing that as b goes to infinity, ln infinity is also infinity, right? This is infinity. In other words, this corresponding integral, it diverges, so does our original series diverge. So that's the integral test. But also, the integral test, it has a lot of restrictions by the corresponding function here. It should be non-negative term, and then it's non-increasing for this function. Most of the time, how to check the non-increasing? Well, you take the derivative to make sure that the function is non-increasing. That's the way how it handles. Okay, so it does have a couple of criteria to use. Okay, all right. So then that's number 15. Number 16. So use a comparison test to determine. So I'll leave this one to the next video. How about that?